It's got to be in radians before. And I'm looking through all these exams right now and seeing if at any time you have I find a question where your calculator has to be in degree mode. I haven't found it yet. So we may just stay right in radian mode and not have to worry about anything because it won't affect anything else. So plug 19 in the equation, and at 7 p.m. it's going to be 77 degrees. And we tried this last period. We put our calculators in degree mode and plugged in 19, 74. You get out. Oh, shocker. It's a choice up there. Okay, so we got to be in radian mode. All right, we okay? Yes, go ahead.
Why would it be like for the x value? Why wouldn't it be like -5? Because like I thought it would be like 5 hours before 12.
But after.
Okay.
I got you there after midnight. So I got to go past. All right. After midnight. All good. All right, you ready? 23. Whew, we're seeing this more and more now, right? These 3 equations, 3 variables. Which one's not a solution? All right. And I want to make sure, I want to make sure you guys are prepared to answer this if this was a part 3 question and you had to do this find X, Y, and Z all by yourself. Not a multiple choice question like this. And this is not a store problem, unfortunately. All right, so I have 3 equations. I'm going to just number them 1, 2, and 3. First step, pick 2 equations and eliminate a variable. Okay, so look at the 3 equations you have. Make your life easy. Which 2 do you want to pick so a variable maybe would eliminate right away? So step 1, 1 and 3. Okay, here we go. X plus Y minus Z equals 6. Right underneath it, equation 3, -x plus 4y minus z equals 17. Good choice because the x's are gone. Now you do have to combine everything else though. How many y's do you have left over? 5y. The z's do not cancel. They're not opposite. Minus 2z. And then 6 and 17, 23. Leave that equation. We'll come back to it in a second. So eliminate a variable easily. Next one. Next step. Now we have to pick 2 more equations, 2 different ones that we just picked. And now you have to eliminate the same variable you just eliminated, which is x for us. So I'm going to make it a class decision here. Which 2 do you want to put together now? First, I don't care. There's no wrong answer here. You want to pick 2 and 3? 2 and 3?
Yeah.
Is everyone all right with that? 2 and 3? All right. So 2x minus 3y plus 2z equals -19. And then right below it, -x plus 4y minus z equals 17. Whoa. Relax, Tim. Relax. We're getting here. Do the x's cancel? No, they don't. So you have to make them cancel by multiplying one of these equations by a number so that the x's will cancel, because right now they're not. So what can I multiply by, and which equation can I multiply it by to eliminate my x's? Because right now it's 2 and -x. Multiply it. Go ahead, Aaron. Multiply the bottom by
2.
Everyone agree? If I multiply the bottom by 2, they will cancel. Now, when you multiply by a number, you have to multiply every single thing, including after the equal sign by it. So here you go. You can do it with me. -2x plus 8y minus, we're going to get a twofer here, huh? 2z equals 34. It's got to distribute all the way through, including the other side of the equal sign. Ooh, look at you guys. What happened here? My x's are gone. Ooh, wow, and the z's are gone. Look at you guys. Lucky you. All right. So how many y's do I have left? 5y equals negative 19 plus 34. 15. Y equals 3. Okay, so it can't be choice 3 because we're looking for which solution it's not. How can you find another variable? I know what y equals now. How can you find another variable? Don't do any more hard work, Nick. Ready? Take y equals 3. Remember this equation you did at the beginning? Plug it in and solve for what variable now? There you go. Once you find a variable, you're done with the hard work. Plug it in to find the other two. So go ahead, plug 3 in for y and find what z is now. And what do we have here? Z is going to equal -4. Yep. So now you have z, you have y. Now you go all the way back up to the top and plug it into one of the original 3 to find your x value. And are we getting x equals -1? So the only value that wasn't part of our solution was 2. Pick 2 equations, eliminate a variable. Pick 2 new equations and eliminate the same variable. If you want to reach out, I can give you a slew of these on Delta Math if you need them. Reach out if you need more practice with this. Anything else? I got one more and that's it. Like I said, as the days move on, I don't do as many problems up here and you guys get the practice. All good? All right, let's do a graphing one to end this. Let's go to part 2, number 27. Part 2, number 27. All right, you tell me, you see this next Thursday, where are you going? You got to graph it, right? So everyone's hitting up y equals. All right, I have a question because let's say I've been absent for a while. How do I get that log button in there, huh? Because I can't use this log button to the left over here. Math, or you can go alpha window. Either way is going to get it there for you. All right, if you go math, you got to scroll down a little bit more, or you can go alpha window to get it. Number 5, 2, x plus 6. We could take a, ooh, look at that graph, huh? I want me to graph that. How do I find what point? I'm not, you, by the way, if you just look at your graph and just do a little quick something on your, get out of here. No chance. How can I find actual points that are on here? Table, right? Second graph. And you graph as many whole numbers as your graph will hold. All right. So let's see. -5, 0, -4, 1. Those should all be points you should be graphing. -4, 1. -2, 2. 2, 3. think it's 10.4. There's another one, 10.4. And here's the deceiving part. Your calculator let you down. It didn't show you the whole thing. Okay, your calculator's not showing you the whole thing. And I'll show you why. And this only goes for log equations. Now, some of you, and this is what a lot of kids did when they took this exam, they just went to about right here, made it like a random point because that's what my window showed me, and did this business right there. You'll probably get a point out of 2. All right, but here's the thing. It actually continues down. All right, the graph actually continues down. Now, if you go back to your table, what happens after I hit -5? If you keep going back, I start getting a lot of errors, right? I start getting a lot of errors. Here's why. That means at -6, your graph's going to get awfully, awfully close to -6, but never hit. And your calculator, for some reason, won't show you that. This is for a log equation only. Log equation only. Why is mine wrong still? Got to have arrows, right? If I'm not giving an interval to graph over, got to have arrows both ways. So that's what the full graph looks like. Log equations only. They'll come awfully close to a number but never hit. And the last thing before I let you go, anybody know what this is called right here? This line that it comes awfully, awfully close to in case it ever comes up? It doesn't need to be in your graph here. Anybody know what that line is called that comes awfully, awfully close to but won't hit? You want me to spot you the first letter? A.
And the second letter.
Do you need a second letter, Dylan, or you got it?
Second letter.
S.
Asymptote.
Asymptote. Yep. It's
How
called.
do you know which thing it will come close to? Is it
Well,
just
I
like
start.
the one
Look
that
at your
follows?
Jared. Look at your table.
So it's
Do you see? I start getting errors right after -5.
Yeah.
So that means negative. The next one, -6. It's never going to hit.
Okay.
Okay. All good? All right, here you go. Let's get to work. Those are the 5 I'm suggesting today. Let me just stop the video real quick and I'll put them back up.